Hi, my name is Chris Gerber, and this is my final project for CSCI E-175 at the Harvard Extension School. For this project, I worked with the Amazon Glacier service. To begin, I'll provide an overview of my project. I'll provide an overview of the technology that's provided by Amazon. I'll review the proposed solution that I came up with, the implementation of that solution, and then the learnings that I came to through this process. The first real goal of this project was to actually understand the Glacier service. Beyond that, I identified another problem. My problem was that I have a number of lossless music files on my laptop, and these files require far too much space. These files don't change once I've recorded them, and I typically use them less than once a year, simply to transcode into other formats that I can then use on, for example, my iPhone. These smaller files I use regularly, but the larger files just sit on my disk taking up space. So I thought, as we do with all things in this class, the solution is move them to the cloud. So I began looking into the Glacier technology. Glacier itself is a low-cost storage solution. It's very cost competitive. It's as low as 1 cent per gigabyte per month. It's a secure and durable solution. We use technologies such as secure socket layers to transfer to and from Amazon services. We use advanced encryption standard for the actual storage of the files so that we know that the files are protected. And we also have access to Amazon's identity and access management solution, so we can control who actually has access to these files. Amazon quotes a 99 and 99's annual durability. Durability is not a metric I was familiar with. I'm assuming this means 1 in a billion files could potentially be damaged. Typically, we talk about reliability, in which case 99's would refer to less than 31.5 milliseconds of downtime per year. The solution is simple and flexible. It can grow and shrink on demand. You only pay for your actual usage. And it gets away from typical archive challenges, which include things like tape handling and storage. We don't need to worry about it in this case. The other key thing that I identified was that this technology is based on the idea of vaults and archives. So vaults in this case essentially work like directories or folders where you can store a number of archives. And archives are essentially individual files. But typically, rather than a one-off file, like a single song in my case, an archive would be a collection of songs that have been bundled up in a zip format or a tarball or some other compressed archivable format. We can compare the Glacier service to something like S3, which we've looked at more closely in this class. Looking just at pricing alone, we see that the Glacier service is actually about 8 to 10 times cheaper than S3 for storage. Where the price gets more expensive is actually with uploads and retrievals, where it's 5 times more expensive. But ideally, this is a solution where we're not accessing these files regularly, so once they've been stored once, that cost is gone, and then we're only dealing with the storage costs. We do see that things like deletes and data transfer in is free, which is great, in both services. And data transfer out for the first gigabyte per month is free. But then we get to larger tiers, such as up to the first 10 terabytes of data transfer out, the prices are actually the same. The other key thing to highlight is the difference in the tools. S3 provides GUI tools, command line tools, API tools. It's a very full-fledged suite of commands and interfaces that we can use to help work through these things. Glacier, on the other hand, has a very limited GUI and limited API. So essentially with the GUI, all you can do is manage vaults. You cannot take an archive and move it in or out of the service. And the API is somewhat limited as well. It is only available currently for Java and .NET. whereas S3 has a lot more Amazon-supported API tools, such as access to languages like Ruby, which would be my first choice. I did see tangentially that using a Ruby gem called Fog, you can actually access these services, but it's not formally supported by Amazon, so I haven't looked at that in detail at this time. So the solution that I came up with for my problem is to create a set of command line tools that would let me store my music files in the cloud. I wanted to create a single Java jar file that I could use to manipulate vaults and archives, have it work similarly in appearance to the EC2 command line tools, and by creating these tools once, I could then integrate with other things such as the Ruby language by calling these tools as needed. So you can see I've created basically 7 things that I needed to focus on. Vaults needed to be able to be created, described to tell me what is in a vault, deleted, and listed to see which vaults I have. And archives need to be able to be uploaded, downloaded, or deleted. In addition to this basic functionality, I also needed support for a debugging mode so that I could test these tools without actually making changes on the Amazon service. So the first 2 tools look a little like this. So if you want to create a vault, you'll see that all these commands begin with java-jar glacier.jar, which basically just runs the application. To create a vault, we use the --create-vault option, or just -c, and we specify a vault name with the vault option, so --vault test. And you'll see it simply creates a vault, and it uses a unique serial number for me, that 887 number. It goes into my vault folder and creates a new folder essentially called test. I can then list my vaults, and you'll see that the vault that I just created was successfully created. It does not yet have any archives, and it does not yet use any storage space. And that was done simply through that same glacier.jar, but using the --list-vaults option. The next command is print-vault, which prints the details about a single vault. So we'll see the same vault that we just saw, and you'll see a creation date, a last inventory date, the number of archives in there, the size in bytes, the actual path to the vault, and the name of that vault. And likewise, we can also delete vaults using the --remove-vault command and specifying an appropriate vault. To upload a new archive to the vault, we use the --upload option. It allows us to specify a description. So in this case, in quotes, I've specified glacier code. It requests the file, so --file glacier.jar, and the vault to store it into, so --vault test. The file glacier.jar is simply the command tool that I created, and just as a simple test, I wanted to upload that into the service to see how things work. So you'll see that it begins uploading the file. It creates an archive ID, this very long, unique ID, and uploads a number of bytes. You'll see it says part uploaded, and it shows a checksum. Basically, this command will complete quickly, but the archive will not be usable for 3 to 4 hours. And that's one of the trade-offs of Glacier. While it's very cheap for storage and for retaining files for a long period of time, the actual transactions are very slow. So it's really intended for situations where you're not going to change these files much at all. I mentioned parts. In my case, I set a part size of 64 megabytes. And basically the idea is with parts that you can sort of parallelize the uploads by segmenting these larger archive files into smaller chunks. I was working on the idea that I would want to send about 75 archives, about 200 files per archive, and about 30 megabytes per file. So based on this idea, I would come up with an average archive that is about 100 parts that could then be parallelized during the upload process. The maximum parts that you can ever upload through this service is 10,000, and the maximum part size is actually 4 gigabytes, which means your maximum archive size is actually an amazing 40 terabytes. I mentioned you can parallelize, although you could have 10,000 parts, only up to 1,000 parts can be run in parallel at a time. Next, I go to download my archive. And the command structure is again similar. I use --download, and I have to specify that very long ID for the archive as opposed to a friendly name. You'll see in this case I'm saving it to a second file name, glacier2.jar, just to confirm that things are working correctly. Now, as I mentioned, files are not available for 3 to 4 hours, so I started this command and walked away from my computer and actually woke up the next morning to see that my file did in fact actually download. Deleting archives is also similar and also straightforward. You use the Java command with --delete, the ID for the archive, and the vault to delete it from. And this command will finish apparently immediately, but the change will not actually take effect for 3 to 4 hours as well. Now, as a tangent, you can actually use simple notification service to create notifications for when these tasks complete. So you could receive, for example, an email when the process is done. If I had immediately listed the contents of my archive right after this delete, you would not see an actual change. But after the process does complete 3 to 4 hours later, my archive would then be shown as deleted from my vault. So what did I learn from this process? Glacier is actually ideal for a long-term archiving from frequently needed files, and is actually a really good fit for the type of data that I'm trying to store. The APIs were actually relatively easy to code against. I was able to write all the code in basically an evening and have it work correctly with almost no debugging. It was really straightforward. It was interesting to note the first bug that I did hit was that part sizes must be in megabytes and must be a power of 2. So you can't set a part size of, for example, 10 million. You would have to figure out what 1,024 times a megabyte is and do that math. And the last thing was I found that my command line interface makes Glacier very easy to use. So I was very happy with this project. I was very happy with the learnings that I got from Glacier. I think it's an amazing service, and I hope that you've enjoyed this presentation and enjoy using the service as well. Thanks so much.